Okay, sorry, I put you the wrong button. Today will be the week 13. Nice. So the week 13. We are going to have a check. Okay, so week 13. So today I'll finish the lecture of SVM. And so that's the end of all the computer vision machine learning. So, so today I will start just focus on after the SVM, all the lecture will be the deep learning. So start teaching about deep learning. And we have the exam week 15. Okay, so it's close book this week. And the range for the beginning to next week what I teach. 就是那个考试范围教到，就是考到下礼拜的那个 lecture 的，就是让 deep learning 大概会教到这边考试。那 close book 是 close book，因为我们教室都约了嘛，这边跟怎么分配他们做，到时候来分呢。考试内容到时候再叫助教稍微在那个什么 Moodle 上面写一下 close book，那就70到90分钟。The time for the exam is about 70 to 90 minutes. It will include the homework. Today we are going to have a homework assignment. I mean, the assignment to you. But the homework we will give totally for the second homework. I'll give you 5 questions, but you only need to take 2. I will tell you which 2 to do that, and then in order to turn it 就5题，你只要写2题就好了。I will give you the 5 questions, but you only need to solve 2 problems. But I will tell you which 2. So we continue the lecture of last week, 2 weeks ago. This one. Okay, we try to finish the supported vector machine. Last time I teach until page 9, but I tried to teach you again for a little bit. So this is a 9. The important thing is for discrimination. This example is try to discriminate 2 parts, like a phase and non-phase. So we use a 9. Okay, but previously we used a linear discrimination. But here we try to use a non-linear because in reality, most of distribution are non-linear distribution. So first, before that, we talk about this one. This is not the discrimination 9. Okay. So this is equation, a 9 equation, this one. In the x1, x2 coordinate. So this one become, okay. And the important one is because we are using the vector matrix. So this will be basically this format. And you can do it Q, P1, and X1, S2, 1. Actually, PQ and sorry, Q, P, and PQ, and this will be X1. So it will be complete AS equal to B problems. And this equation will represent this format. And for the physical meaning, my example will tell you like this one. I will give you this equation. And I will ask you, what's the physical meaning of W? I will give you like 5 selections. 我会给你4个选择，5个选择这样子，不会让你去背的。 So I ask you, what's this one? So this will include rotation, scaling, and this is translation. But in this case, here's without scaling, just the rotation. So this one will W will control rotation of this line, and W actually is the normal direction of this line. So W will be like a pass through the 0, 0 here. 这有一个 W 法向量会穿过零零，所以 W 是控制线的旋转量 W。So this control the rotation vector of this line. And B is what? B is the translation. So if B is equal to 0, and this line will be passed through the origin. So we see the next one. So this is W. So W will control the rotation of this line. And this line basically is suppose 2 points, XA and XB, so become the vector. XA and XB, so become a vector. And so that we can represent this line by this kind of format. So the two vector, one is the XA, XB. The other vector is the normal direction. And because they are orthogonal, so the inner product will be 90 degrees. So the inner product will be 0, this one. Okay, so that's the representation for this line. We say again. So if this one, so if B is equal to 0, meaning the distance here. So B is the distance here from the point. This is a point to the line. So this is the B distance here. So so if B is equal to 0, that's meaning this line will pass through the origin. Okay, we'll keep going. This one, if B equal to 0, this line pass through the origin. This one. So this line will shift along the normal direction. So this one will shift along the normal direction. That's translation. Okay, so it continues. So based on this one, so the other one what try to tell you is inner product. So we have an A. Suppose a vector A, and this vector B. So the relationship between vector A and the vector B is that if A project to the B, and if A has more projection weight or more component on B, that's meaning the two vectors will close to each other. Inner product, that's mean projection. Okay, so this is projection. So what's the projection mean? Projection is A project on B and equal to this one. This is what is this one? This is the magnitude. 这是大小嘛 ，A 的大小，这 B 的大小，这绝对值代表距离，距离代表大小。Now this is equation. So if A project on B is meaning cosine A times cosine theta. Cosine theta is between the angle between two vectors. You already know. So what's this one? Because this one is this here. So we'll find A project on B equal to the A, this A, project on the unit vector of B direction. Unit vector is a direction. 我们讲过 unit vector 是一个方向，所以意思 A project on cosine theta, A do cosine theta is meaning A project on this direction, this unit vector. A 会投影到这个方向，这样子，所以这个物理意义就是这个物理意义，所以这是一个 unit vector 这样子。那这个很重要，意思是说我们两个字 the relationship between two vector. So if I'm the base, I'm the B. So what's our relationship? So if theta equal to 0, that's meaning cosine theta equal to 1. That's meaning we are overlap together. If theta is bigger, so that's meaning you project to me is shorter. Okay, so this is the similarity measure. A cosine theta, this is similarity measure. Similarity measure, actually this is equal to any vector. Okay, what's the component along the other vector? 就任何一个向量在另外一个向量的分量，就代表我们两个之间的相似度这样子。OK， 那最后你会发现这个 before we talk about okay, so what's the physical meaning of not physical? What's the absolute? 绝对值代表什么意思 ？Absolute is meaning distance between the point to the origin. This is a magnitude. 绝对值代表什么？代表大小。So this is called norm. N-O-R-M. So norm has three kinds of norm. First one is the half, is meaning Euclidean distance. 距离有三种，距离有三，基本讲距离有三种，弄就弄一半嘛，1/2，弄 one，弄 two，就是这三种，就弄 NORM。那弄代表什么？弄 what's the non meaning? Non is meaning the distance. Distance meaning what? Meaning the similarity. Distance meaning the similarity. If a distance longer, that's meaning the 2 points, right? The distance meaning from one point to the other point. So distance should be 2 points. So the longer distance meaning the two points will be far away. That's meaning 2 points are not similar. Okay. So this one, if norm equal to half, 就是2/2, let's use Euclidean distance. If norm equal to 1, norm equal to 1, okay, that's absolute distance. If norm equal to 2, that's some square difference. So three kind of measurement. That's the similarity measurement. I say again, similarity measure has three kinds of similarity measure. One is that if it's the distance between 2 points. The first one is the norm, half of the norm, the norm 的2/2代表用 Euclidean distance 就这个，然后开根号嘛，这是第一种。那第二种 the second one is the absolute 就取绝对值，绝对值代表距离。那第三种是 some square difference， 就我们常在用高勋的 exponential term of 高勋的指数部分嘛，它是平方，两点相减取平方嘛，这样子。所以有这三种评估方式啊，所以你要去看。那在 cosine theta， OK， so if this one, what's the cosine theta? Actually, if this one, and then you can, this magnitude 大小嘛，大小 you shift to this one, so become the cosine theta become this one. So that's meaning what? Meaning the relationship between two vector. Relationship between two unit vector. So this is what unit vector A and unit vector B. So this become normalized cross correlation. So when we tell you about normalized cross correlation, actually that's a cosine theta. 我们有讲过嘛 ，similarity measure 除了相减以外，还有一个是相乘。那相乘就是一般来讲是 normalized cross correlation。那 normalized cross correlation 就两个单位向量之间夹角，就 cosine theta。那可以代表什么？代表两个的相似度。所以 NCC NCC is a cosine theta. Okay, and it's the similarity between two unit vector. 这都是讲相似度的两侧。Okay. So we keep going. So so what's the D? D is the distance from the orange to the line. 点到线的距离嘛，是点到线的距离。啊，所以 so what's the D? So if any equation, that's this one, this any equation, right? This rotation, this translation. So if we divide it, actually it's normalized by W. Usually we do normalization, so normalization in the denominator term. 我们实际上希望把它当成一个，就任何东西我要正规化嘛。那正规化我们通常分母就是除上它的大小。NC 也是一样啊，我们要正规化这个，正规化什么 normalization 就是 just between 0 and 1叫正规化啊。Normalization is we try to normalize anything to be 0 and 1. That's probability. 几率的东西。Okay, so this one we normalize by divided. There's a norm of W, and then we will become this term. Okay, so what is this term? You'll find out this term is a distance here from the 0, 0 to x. So suppose x1, x2 are 0, 0. So you put 0, 0 here. This become b, right? Become b divided by w. 原点到线的到这条线的距离就 d 嘛。那 d 的话就把0带进去 x 这边，就这个 term 就0嘛，正常数项，所以 distance 就变成只有这个常数，就这个常数项。那我们通常都忽略 w 嘛，我们通常忽略 w， 但是我们在高中的时候、国中的时候求距离的话，就是为什么要 normalize 要处理这个？因为你希望那个向量那边都是有个就是单位向量这样子啊，所以这个会变成这个层，那这个是我们要的，我会继续讲哈。So here's the most important one are here. So if there's two lines, so the distance between two parallel lines is ds. So ds equal to is d1 minus d2, right? So equal to this one. So finally, the distance between two lines, the parallel line, is constant, the subtraction of constant divided by normalization term. So we need this term. So we keep going. It's not important. What I try to say is this is so back to discrimination. So before we talk about LDA, so we try to find a line. This line we try to separate class 1, suppose phase, class 2 is non-phase. So we try to find this line. But this is not good enough because in our distribution is very easy. There were some samples pass through here and some sample distribute to the other one. So the purpose we try to have some margin. It's called margin. 一个那个算带一个范围叫 margin. So before LDA is just one line. So why SVM is better than LDA is because we are not only need this dash line, we need a margin. So that's two classes can be separated. 就是我们要的，我们之前 LDA 只讲到这个虚线一条线切开两边嘛，但你会发现自然界的分布它会有 overlap。那所以我们的目的是希望不止把两个在 training 的时候，我们不只是一条线，我们是希望把两边推得越开越好，所以就会产生希望有个 margin。那这个 margin 的作用就是 when you do the test, okay, your error rate will reduce. Okay, so we try to find a margin. So in this is the same distribution of class 1 and class 2. So we will find out for the margin 2 is better than margin 1. The same distribution in this case, you'll find out this is wider, this is narrow. So margin 2 is separate, more wider, is better than margin 1. So you will see these two parallel line. Okay, so margin 2, this margin 2, that's meaning you control by this normal direction W, normal vector. 就是说，你这里发现 margin 2是比较宽 ，margin 1比较窄。你会发现主要因素是什么？就是第一个 W 嘛，这个 normal 的形是 W 控制这两条线的旋转嘛。所以你发现你要求这个，就是要求一个最好的 W 出来。这是第一点，还没讲，这是第一点。So we will try to find the better discrimination line. Is meaning we try to find a larger margin. So larger margin will affected by rotation W. So this rotation W will affect the result. The second thing is translation. So previously we talked about only this term. We only zoom in. Previously we talked about only one line, but here is not one line is not enough. We need a margin. So margin is this one. So what's the margin? So margin 是什么？ Margin just we try to find these two lines. Not only one line, two lines. So suppose this line, this dash line will be wx plus b equal to 0. That's this dash line. But we have a small margin. So in this one will be plus k or minus k. We try to be based on this dash line. We try to find a symmetric of two lines become the margin. Okay, so W control the rotation. B is equal to when it's equal to 0. K is the margin. Okay, so K actually is also a translation, constant term. Okay. So if we do that, actually we'll do this way. We still have a normal direction here. It's a normal direction. So one is a 0, the other k and minus k. Okay, so the equation C, so this both plus k equation will become here. And if we divide it by k, because k is the scaling term, 常数项 of scaling term, so you can divide it by k. You'll find out this become w prime x plus b prime equal to 1. Because it's constant term, 这是常数项。So equal to 1. So that's good because here, so we'll become this issue. Original is this issue. But for each parameter term, we divide it by k. 每个参数都 divided by k, 那不会影响，那就会变成这个 term. So you'll find out the margin will be plus 1 and minus 1. That's what we need. So original, this one, original, this 3 lines will become the same 3 lines, but here will become plus 1, 0 and minus 1. 在这里，这样可以哈。Deep learning for the face recognition, deep learning still use this kind of issue. The best face recognition method use this kind of concept, margin. 目前世界上最好的人脸辨识，大陆人发明的，也是用这个观念哦。他把这个观念拿过去这样子。Okay, so we will see. So what's the distance between margin? What's the distance for the margin? Sorry, for the margin. So this margin will become D1 minus D2, this one. And D1 minus D2 equal to this one, B1, this minus B1 and minus B2. This is one is B1, one is the other B2. So finally, you'll find the distance for the margin is this equation. 因为你把它省略变1跟负1，所以它的距离 margin 就变成是这个 term。啊，这是我们要的，因为后面我们就是要这个，我马上讲。Okay. So because this is a plus 1 minus 1, so the distance between two parallel lines, we just talk about this one. 对，我们要讲嘛 ，distance between two parallel lines 就是 ds 嘛 ，ds 是 equal to 这个距离点嘛 ，d1 minus d2 就是这个 distance， 就是这里。那只是我们现在 normalize b1 跟 b2 变1嘛 ，normalize。不是 normal 就是那个，就这边，抱歉，这边，对，本来 k 变1了 ，b 加1 b 加1 b 减1啊，所以最后变成这样子啊，一个 b 加一个 b 减1，so become this one. So the distance for the margin is this one. Okay. And for the label, suppose class 1 is label minus 1, class 2 label 1. Okay, so you'll find out that finally we'll get this result. So this labeling is the same as deep learning cross entropy. The cross entropy, we have a labeling. One is a minus 1, the other 1, or 0 and 1. Cross entropy 那边 deep for the deep learning 有时候是用0跟1嘛，有时候负1跟1。那用0跟1跟负1跟1哪个比较好 ？For the deep learning, right? You read the cross entropy, but you label 0 and 1, right? But for the RetinaNet, they label minus 1 and 1. So which one is better? RetinaNet say this is better. RetinaNet 说这个比较好，这到时候我们讲 RetinaNet 再讲。那这个概念是从这边来的，就 RetinaNet。就我们一开始在做那个 deep learning 的时候，在那个 RetinaNet 之前，大家在做 labeling before RetinaNet. I like RetinaNet. Before RetinaNet, we do labeling. 1 is what we need and 0. Okay, but RetinaNet, based on the supportive vector machine concept, they use this. They feel that's wrong. It's better use 1 and minus 1, and they have a better result. So when we talk about RetinaNet, we'll mention about this one. Okay. So you will find out this word hyperplane. Hyperplane meaning the x1, x2, x3 is high dimension called hyperplane. Because a line, 2D is a line. More than 2D is a plane. So 3D is a plane. 4D is hyperplane. Okay, so this line is dash line. So here, this one meaning if you input any x is meaning sample. Input any x. Suppose you find W, you find B. Suppose you find W and B. So input any x. So if x, this result bigger than 0, that's meaning here. This class 2. And class 2 is label 1. So this class 2. 这边是大于这个虚线大于0是在这一边，然后小于0 minus 1是这一边这样子。This class 2. So class 2 is meaning any x if you input. Suppose you find this this 9, also find this 3 9s. Actually, we only need to find +1 and -1, 9. So if we any x input bigger than 0, that's meaning this part. Smaller than 0 is this part. Okay. That's our definition. So finally, from here, so our purpose is try to maximize this margin. For the SVM, our purpose is try to maximize this region. So that's meaning we try to maximize this region. Maximize this one actually equal to minimize the denominator term. So our equation will become our loss function, our cost function will become this one. Okay. So for the supportive vector machine, originally we want to maximize this one. Maximize this one is meaning we try to separate two parallel lines to have a bigger margin. That's our purpose. So you try to maximize this one is because the W, the rotation term is a denominator term. So that's meaning you try to this here. Maximize this term equal to minimize the denominator term. So become you try to minimize this one. But your constraint will be here. This is your constraint. Originally, we say constraint 0 is meaning this stationary. Right now, we try to have a constraint is equal to margin 9, so this will become 1. Okay, so this your equation and this your constraint. 你的限制就是when label 1乘上这条线，要是属于1嘛，这边嘛。When this is smaller than 1 and this is label -1, there will be the same. There will be complete 成立，这成立，那就是这一边。所以-1这边是-1嘛，-1乘上这条线的负的值，负得正。这边是正1乘上你的奈的正，属于正的这边的，就正得正嘛，就这个。所以这是你的 constraint。那 retina net 就是用这个，它是 y log y。好 ，OK， 好，这个很重要，这是我几乎就讲完了哦。这个你要懂，因为这个在那个when you try to do face recognition, they use this one. So this is your loss function. This is your constraint term. 这样子，记得哈 ，loss function 你们一开始学的很多 paper loss function, when you begin to study deep learning, okay, like 2 years ago, most of loss function has no constraint term. Recent 2 years, the loss function has constraint term. So this kind of constraint term. Okay. So constraint term is something that constraint 就限制嘛，啊，限制就是 is like a margin. OK， 再继续。And this is the other this constraint term. So how can we do become one equation？ 这是 constraint term 嘛？那我们怎么变成一个 equation？ 后面会再重讲哈，应该是讲意思，最后会变成这个，你的 constraint term 就变成这个。哎，对不起，就是 Lagrange 在后面，这个，这是 Lagrange， 这在 page 31。讲一个编的比较对 Lagrange 说，我会讲，我这边后面会继续讲，因为这边中间有跳过去。I say again, this is your original equation, but you only have this equation and constraint term. That when we do the gradient descent, we do gradient descent. How can we minimize this one? Because this is an equation, this constraint term. So actually we'll use Lagrange. Actually Lagrange is here. Page 31 become this one. So you minimize this term. So this constraint term with one scaling factor. 我们刚刚讲是有一个限制，有一个 equation 的那一个限制的条件。可是要整个 minimize 的话怎么做？这是我们一般讲的最佳化的 Lagrange。那 Lagrange 就是你本来的 term 加或减上这个 constraint term 嘛。这我们待会会马上讲。然后你要解W 解 B 解 alpha 这样子，用 gradient descent 方式来解。那这个就是我们的那个 Lagrange， 就是这边这个 Lagrange 的方法。Okay. 所以 recent 2 years people start to use this kind of equation. So original equation plus constraint term. Okay. So the result will be better. We will reduce a lot of noise and have a margin, so you get a better result. So this is page 31. So before we solve this one, okay, here try to tell you the other thing about nonlinear, because this is linear. This is a line. So still a linear constraint, linear equation. And this is a nonlinear. So this result will be better. So if your distribution like this one, this result will be better. Okay. But here, SVM is tell you this way. If you're in a low dimension, you need to separate two classes using nonlinear discrimination. Why not I transfer this space to higher space we call feature space. This is a deep learning do this way. So we use one activation function to transfer from this space to feature space. Okay, and then we use linear discrimination. We can get the same result. So two solutions. One solution is that you can directly use nonlinear discrimination, okay, to separate the classes. What's the nonlinear discrimination like this one? 是多高纬度的，对 ，x1 x2 is 9 right？ 那平方就像这个平方 right？ How can you separate this one? You have a class square and class circle. How can you separate this one in this space? It's not easy. So if we transfer, use the square term 曲线嘛 become this one. So your distribution become this one, and use it in this space. You use a linear discrimination to separate both either way. So you'll find out a funny thing is that 你在这里你会发现，在这里要怎么 separate？ 你要在这里 separate 的话，你要用这种曲线方式嘛？这个你要把这个离开，你就是要想办法找一条线，这样子。对不对？你在这个空间 ，you want to separate two parts, you need to find an equation like this one. 所以这条是你的那个 discrimination curve， 是一个高纬度的 discrimination curve， 这是一个方法。你在 when you in a low dimension, you try to separate nonlinear distribution you need to find a kernel, a function is a high dimension function. 高维的 high degree function to separate. The other way is you use the same, you use high order curve, high order transformation equation to transfer to this new space and use linear discrimination. 就是你要转换的两种方式嘛，一个是在低纬度用高 high degree 的就 x 平方、x 三次方、x 四次方的 curve 来把它分开嘛。那第二个方式是我找一个 kernel function， 实际上这 kernel function 就这个 curve， 把它转到这里，然后用 linear 来做，这样子。所以两个很类似哦，两个很类似。好，那现在问题在什么？那 how many order of the equation you want to have？ 那你要找一个几次的方程式，几次的非线性把这个区分开，这是一个问题。那这是this is activation function。你要找像以这个来讲的话，它找一个10次的曲线，这个10次曲线，所以把它 project to this order equal to 10 the space from 3 degree to 10 degree， 就10维，从3维到10变到10维，然后再去做区分，所以这很麻烦。那 deep learning doesn't do this way. Deep learning is each time just do a little bit transfer. But supportive vector machine is from only the original space, and suddenly they jump to a very higher dimensions. SVM 是不管的，因为它不知道要到几维，它就直接到高维去了这样子。好，那这里是要跟你讲这一件事情，就这个一个纬度。那这样从 when you reproject to high dimension, you can separate use linear discrimination。所以你到高纬度以后，你就可以用这个方式来处理嘛。这是高纬度，那这里是高纬度 ，x 就变高纬度了。啊 ，so SVM is meaning when you first of all you need to find actually they define a very high dimension transformation. You reproject to very high dimension and use high dimension plane to separate to do discrimination. 这是 SVM 的概念。OK， 好，我们再继续。So for SVM, they design the kernel function as this one. 这是 SVM 我们讲，那 kernel function 就是我们的 activation function in deep learning。那你会发现，像这个 kernel function， 这第一要几维，2维不够，4维、9维就变得很复杂。这都可以到高维，都很复杂。这是 SVM 的缺点，就你纬度要自己去把它调到很高，这样子。所以它是一个 problem depend， 这个很难，你也不知道到几维，当然是你就不知道就把它用到高维去，这样子。那但是这里它用到一个概念 ，SVM 从这里导入一个概念，就是 kernel function 的概念。所以 what's the meaning for the kernel function? First of all, they do space transform。那这个也是啊 ，space transform。做空间的那个转换 ，space transform 是 kernel function。好，那这里就讲到，就引入 kernel function 的，就 activation function 在这里，就 SVM 也会导入这个。好，那我们再回到，所以它有用到 sigmoid， 但它 sigmoid 比较复杂。好，再来。 那我们回到刚刚这边哈，我们刚刚讲到这里嘛，刚刚讲到这里，那我们继续。这要跟你讲什么？也叫 soft margin。什么叫 soft margin? It's meaning no matter how you separate, they still have some sample will overlap. No matter how you do the margin, they still have some samples will pass through this margin and cause the error. So our purpose, we try to push this one back to there. That's attenuation. So we will change. 这个你自己看 we will change our margin become this one. Original constraint is only one, but right now our margin will change to be this one plus this term. So this is what? This is this one, this term. This is one. One minus this one become this small margin. So that's meaning you allow a little bit error. 就是你这个 margin 再怎么推都没办法完成，那你就把这个错误引进来，导入进来。所以这里有个错误，所以这个是一哦，从这里到这里是一，那一减掉这个 n 的话，就剩下这个距离，这样子。那这是负的，因为这边是负的，所以一减掉这个，这边一加上，就是你本来是一，再加上这个距离，就是你要把那个错误的东西带进来。那但见你再把它 minimize 就变减少错误啊。观念是这样，你本来是0嘛，0是希望它完美，就这里都没有东西，可是在实际上这里还是有错误，那怎么办？我就把错误的东西带进来，所以我们减上一个这个，减的这个意思就是说，你本来 margin 是1，你减掉这个是我扔2的话，你现在的错误，你现在会就这个会变成只剩下这个距离，所以你允许它有这个错误。反过来，这个 x3 你只有扔3，那因为你这是负的，这边是负的，所以实际上是1加上这个错误率，这因为这是负的，所以加上这错误率就变成你有大的这个错误的东西。那因为我们的目的是要把我们刚刚一开始讲，我们的目的是要 minimize 这个结果，所以你要把这个错误就把它 minimize 掉了，这样子。所以你允许它错误，但是你要把错误 minimize 这样子。那这个 deep learning 还没有带进来 ，deep learning 还没有把这个因素带进来。我现在看到 paper，deep learning 大概就没有把这个带进来，就是大于1这样子而已。OK， now I mean up to here, and then we'll continue this lecture next hour. 我们下课一下哈。